guys. This is Dr. Ding Dong. Actually, my real name is Dr. Einstein. And welcome to Grey's Anatomy. Okay. I would like to cover a few different parts of the human anatomy in this morning's lecture. Let's see. I'm usually doing the brain, but I like doing some of the the parts of the female anatomy. Let's see. Okay, here we go. The pyramidalis is a small muscle, triangular in shape, placed at the lower part of the abdomen in front of the rectus, and contained in the same sheath with that muscle. It arises by a tendinous fibers from the front of the pubis and the anterior pubic ligament. The fleshy portion of the muscle passes upward, diminishing in size as it ascends, and terminates by the pointed extremity, which is inserted into the linea alba, midway between the umbilicus and the os pubis. This muscle is sometimes found wanting on one or both sides. The lower end of the rectus then becomes proportionally increased in size. Occasionally, it has been found double on one side, or the muscles of the two sides are of unequal size. Sometimes its length exceeds the stated above. What is stated above? Besides the rectus and pyramidalis muscles, the sheath of the rectus contains the superior and deep epigastric arteries and the terminations of the lumbar arteries and the lower intercostal arteries and nerves. The abdominal muscles, abdominal, are supplied by the lower intercostal nerves. The transversalis and the internal oblique also receive filaments from the hypogastric branch of the iliohypogastric and sometimes from the ilioinguinal. The cremaster is supplied by the genital branch of the genitocrural. In the description of the abdominal muscles mentioned has frequently been made of the linea alba. Is that Jessica Alba's sister, Linea Alba? No, I'm just kidding. Just a little Grey's Anatomy humor. Okay. Linea seminalis and linea transversa. When the dissection of the muscles is completed, these structures should be examined. The linea alba is a tendinous raphe seen along the middle line of the abdomen, extending from the ensiform cartilage to the symphysis pubis, to which it is attached. It is placed between the inner borders of the recti muscles and is formed by the blending of aponeuroses of the obliqua and transversalis muscles. It is narrow below, corresponding the narrow internal interval existing between the recti. The broader above, as these muscles diverge from one another in their ascent, becoming of considerable breadth after great distension of the abdomen for the pregnancy or ascites. It presents numerous apertures for the passage of vessels and nerves. The largest of these is the umbilicus, which is in the fetus transmits the umbilical vessels, but in the adult is obliterated. The cicatrix being stronger than the neighboring parts. Hence, umbilical hernia occurs in the adult near the umbilicus, whilst Must have been written by an English person whilst. In the fetus, it occurs at the umbilicus. The linea alba is in the radiation in front with the integument to which it is adherent, especially at the umbilicus behind. It is separated from the peritoneum from the transverse fascia and below by the erectus in the bladder where the organ is extended. The linea seminars that are curved tendons line placed on each side of the linea alba. Okay, enough of that. I'm going to go to another one now. Another part of the anatomy. Let's see. Something I haven't done yet. I always like to cover the. Well, maybe I'll go to the brain next, and then I'll go, and then from there I'll go to. Okay. Do you feel like hearing about the medulla oblongata or the? Let's see. The brain and its membranes. The size of the brain is formally said to bear a general relation to the intellectual capacity of the individual. Culver's brain weighed more than 64 ounces. That of the late Dr. Abercrombie, 63 ounces, and that of Dupuy-Yetram, 62.5 ounces. On the other hand, the brain of an idiot seldom weighs more than 23 ounces. But these facts are by no means conclusive. It is well known that these weights have been equaled by the brains of persons who never displayed any remarkable intellect. Dr. Heldenen of Cincinnati has recorded the case of a mulatto, age 45, whose brain weighed 68 and 3/8 ounces. Never regarded as Dr. Ensner, district medical officer at Port Elizabeth, reports that the brain of Carey, the Irish informer, weighed 61 ounces. M. Nikiforov has published an article on the subject of the weight of brains in the Novosti. According to him, the weight of the brain has no influence whatever on the mental faculties. It ought to be remembered that the significance of the weight of the brain should depend upon the proportion it bears to the dimensions of the whole body and to the age of the individual. It is equally important to know that what the cause of the death, for example, for illness or age, exhausts the brain. To define the real degree of development of the brain is therefore necessary to have a knowledge of the condition of the whole body. And, as this is usually lacking, the mere record of weight possesses little significance. The human brain is heavier than that of all the lower animals, excepting the elephant or whale. The brain of the former weighs from 8 to 10 pounds, and that of a whale is a specimen 75 feet long, weighed rather more than 5 pounds. Cerebral, localization, and topography. Physiological and pathological research have now gone far enough to prove that the surface of the brain may be mapped out into a series of definite areas, each one of which is intimately connected with some well-defined function. And this is especially true with regard to the convolutions of either side of the fissure of Orlando, which are believed to be, by most physiologists of the present day, to be concerned in motion, those grouped around the fissure being associated with the movements of the extremities of the opposite side of the body, and those around the lower end of the fissure being related to the movements of the mouth and tongue. This is not the place, nor can space begin to describe these localities. But the two accompanying cuts from Ferrier have been introduced and will serve to indicate the position of the more important areas. The relation of the principal fissures and the convolutions of the cerebrum to the outer surface of the scalp has been the subject of much investigation. And many systems have been devised by which one may localize these parts from an examination of the external surface of the head. These plans can only be regarded as approximately correct for several reasons. In the first place, because the relations of convolutions sulci to the surface are found to be very variable in different individuals. Secondly, because the surface area of the scalp is greater than the surface area of the brain. So that lines drawn on the one cannot correspond exactly to sulci or convolutions of the other. And thirdly, because the sulci and convolutions of the two individuals are never precisely alike. Nevertheless, the principal fissures and convolutions can be mapped out with sufficient accuracy for all practical purposes, so that any particular convolution on the can be generally exposed by removing with the trephine a certain portion of the skull's area. The various landmarks on the outside of the skull, which can be easily felt and which serve as indications of the position of the parts beneath, have been already referred to. See, in relation to the fissure, the convolutions of these landmarks as follows. Longitudinal fissure. This corresponds to a line drawn from the glabella at the root of the nose to the external occipital protuberance. The fissure of Sylvius. The position of the fissure of Sylvius and its horizontal limb is marked by a line starting from a point 1 1/4 inches horizontally below the external angular process of the frontal bone to a point 3/4 of an inch below the most prominent point of the parietal eminence. The first 3/4 of an inch will represent the main fissure, the remainder the horizontal limb. The bifurcation of the fissure is, therefore, 2 inches below, behind about a 1/4 inch above the level of the external angular process. The ascending limb of the fissure passes upward from this point parallel to and immediately behind the coronal suture. Fissure of Rolando. To find the upper end of the fissure of Rolando, a measurement should be taken from the glabella to the external occipital protuberance. Okay, I'm going to go to another part of the human anatomy. Something I haven't done yet. Let me see. I want to talk about the, let's see. Now, are you going to remember this? Or are you going to be quizzed on it tomorrow? Okay. Let's see. Let's go with the skeleton. Wait a minute. Wait. Let's see. Yeah. Okay. The fibula is situated at the outer side of the leg. It is the smaller of the two bones, and in proportion to its length, the most slender of all the long bones. It is placed on the outer side of the tibia, with which it is connected above and below. Its upper extremity is small, placed toward the back of the head of the tibia and below the level of the knee joint and excluded from its formation. The lower extremity inclines a little forward so as to be on the plane anterior to the upper end, projects below the tibia and forms the outer ankle. It presents for examination a shaft and two extremities. The upper extremity or head of its irregular quadrate form, presenting above a flattened articular facet directed upward, forward, and inward for articulation with a corresponding facet in the external tuberosity of the tibia. On the outer side is a thick and rough prominence, continue behind into a pointed eminence, the styloid process, which projects upward and from the posterior part of the head. The prominence gives attachment to the tendon of the biceps muscle and to the long external lateral ligament of the knee, the ligament dividing the tendon in two parts. The summit of the styloid process gives attachment to the short external lateral ligaments. Okay, enough of that. The nervous system? Wait a minute. How about, let me see, what do I feel like discussing? I want to go with the eye. Okay, the eye. Let's see. Um, the eyeball is contained in the cavity of the orbit. In this situation, it is securely protected from injury, whilst its position is such as to ensure the most extensive range of sight. It is acted upon by numerous muscles, by which it is capable of being directed to different parts. It is supplied by vessels and nerves, and is additionally protected in front by several appendages, such as the eyebrow, eyelids, etc. The eyeball is embedded in the fat of the orbits, but is surrounded by a thin, membranous sac, the capsule of tenon, which isolates it so as to allow of free movement. The capsule of tenon consists of a thin membrane which envelops the eyeball from the optic nerve to the ciliary region, separating it from the orbital fat and forming a socket in which it plays. Its inner surface is smooth and it is in contact with the outer surface of the sclerotic. The periosclerotic lymph space, only in intervening. This lymph space is continuous with the subdural and subarachnoid spaces and is traversed by delicate bands of connective tissue behind the ciliary vessels and nerves and by the optic nerve, which being continuous with the sheath of the latter. In front, it blends with the ocular conjunctiva, and with it is attached to the ciliary region of the eyeball. Is perforated by the muscles which move the eyeball, and on each it sends a tubular sheath. The sheath of the superior oblique is carried as far as the fibrous pulley of that muscle. That on the inferior oblique reaches as far as the floor of the orbit, to which it gives off a slip. The sheaths on the recti are gradually lost in the perimysium, but they give off important expansions. The expansion of the superior rectus blends with the tendon of the levator palpebra, that the inferior rectus is attached to the inferior tarsal plate. These two recti, therefore, will exercise some influence on the movements of the eyelids. The expansion of the sheaths of the internal and external recti are strong, especially that the one from the latter muscle, and are attached to the lacrimal, strong, especially and malar bones, respectively. And they probably check the action of these two recti. They have been named the internal and external check ligaments. Lockwood has also described a thickening of the lower part of the capsule of tenon, which he has named the suspensory ligament of the eye. It is slung like a hammock below the eyeball, but being expanded in the center and narrow at its extremities, which are attached to the malar and lacrimal bones, respectively. The eyeball is composed of segments of two spheres of different sizes. The anterior segment is one of a small sphere and forms about 1/6 of an eyeball, of the eyeball. It is more prominent than the posterior segment, which is one of a much larger sphere, um, and forms about 5/6 of the globe. Uh, the segment of the larger sphere is opaque and formed by the sclerotic, the tunic of protection to the eyeball. The smaller sphere is transparent and formed by the cornea. The term anterior pole is applied to the central part of the anterior curvature of the eyeball, and that of the posterior pole to the central part of the posterior curvature. A line joining the two poles forms a sagittal axis. The axes of the eyeballs are nearly parallel, and therefore do not correspond to the axes of the orbits, which are directly outward. The optic nerve follows the direction of the axes of the orbits and are therefore not parallel. Each enters its eyeball about 1 millimeter below and 3 millimeters to the inner or nasal side of the posterior pole. The eyeball measures rather more in its transverse and antero-posterior diameters than its ventricle net diameter, the former amounting to nearly an inch, the latter to about 9/10 of an inch. The eyeball is composed of 3 investing tunics and 3 refracting tunics of the eye. So the reason I'm covering the eye is because I'm always fascinated by human eyesight. I mean, it's like when you think about it, it's one of the most fascinating parts. To me, the most fascinating parts of the human anatomy are those parts of the human anatomy which are defining characteristics that are uniquely human. And I suppose animals also have sight too, and that's true too. But human sight is more sharp and acute, and it's that the eyesight is like directly correlated to the brain functioning and just the connection between and like what is eyesight, and is that still part of the imagination? Is that still like how can you define eyesight? And I mean there's the occipital lobe of the brain, there's like the optic nerve that goes from the eyeball, the light from an image lands on your retina, and then that's light, that information travels along the optic nerve into the brain, where it forms an image in the brain. And like a philosophical question can also be raised when pondering these types of biological functions, as to, is the color orange the same to me as it is to you? How can you define like what I see when I see the color orange? How can I describe the sensation, the visceral experience of viewing the color orange as compared to your experience of viewing orange? When you see orange, is it the same experience in your brain as my viewing of the color orange, or is it different? So some of these things are like philosophical questions that can be raised when considering some of these, biological functions and brain functioning and awareness and the life of the mind and stuff like that. Which is why I'm really fascinated by certain parts of the body, like the brain and the eyes, and it's kind of the parts of the body that give us our humanity. Okay, so tunics of the eye. From without inward, the 3 tunics are 1, sclerotic and cornea; 2, choroid, ciliary body and iris; and 3, retina. 1, the sclerotic and cornea. The sclerotic and cornea, from the external tunic of the eyeball, they are essentially fibrous in structure, the sclerotic being opaque and forming the posterior 5/6 of the globe, the cornea, which forms the remaining 6 being transparent. The sclerotic has received its name from its extreme density and hardness. It is a firm, unyielding, fibrous membrane serving to maintain the form of the globe. It is much thicker behind than in front. Its external surface is of a white color and is in contact with the inner surface of the capsule of tenon. It is quite smooth, except at the points where the recti and oblique muscles are inserted into it, and its anterior part is covered by the conjunctival membrane, hence the whiteness and brilliancy of the front of the eyeball. Its inner surface is stained of a brown color, marked by grooves in which are lodged the ciliary nerves and vessels. This is loosely connected by an exceedingly fine cellular tissue, lamina fuca, or fusca. With the outer surface of the choroid and an extensive lymph space, perichoroidal, intervening between the sclerotic and choroid. Behind it is pierced by the optic nerve, and it continues with its fibrous sheath, which is derived from the dura mater. At the point where the optic nerve passes through the sclerotic, this tunic forms a thin cribiform lamina, the lamina cribrosa. Minute orifices in this region serve for the transmission of the nervous filaments, and the fibrous septa dividing them from one another are continuous with the membranous processes which separate the bundles of nerve fibers. Okay. So I think it's like the whole reason to learn to have an intimate knowledge of this. Pretty much, this book is like, most of this book is just like kind of like a classification of different like body parts that they've identified. What's most interesting to me is like the functionality of the body and how like these different organs and different systems within the body interact with each other and how they all collaborate to form what we know as a human being, how they work in partnership to send messages from one body part to another, from the brain to the muscles of the body, for muscle movements and eyesight and emotions, human emotions. And is there something that goes beyond the physical, the material? Is it all material? Is it all materialism? Some scientists say that it's all materialist. Scientists say that it's all material. That we are just merely machines that actually react to different things, which would imply that we have no free will. I like to think that there is a human free will, and that there is something that goes beyond the material, something that is like transcendent, that what we would call a soul, that interacts with the brain, the composite of which is the mind. I mean, there's certain theories in quantum physics that would espouse this point of view, that the mind gives rise to the brain, and not vice versa. The materialist scientists believe that the brain is an epiphenomenon of the mind, and some of the quantum theorists believe that the mind gives rise to the brain, and that that's what brings the brain into existence, and that the mind is eternal, and anything material is actually that's the immortal part. That's the mortal part of the full human package, or whatever. Anyways, okay. So anyway, And some of these theories have been verified by experimental data. Um, some of Einstein's theories have been definitely validated, but then people like Niels Bohr and Erwin Schrödinger stepped in to actually augment some of his theories. I mean, Einstein was right on about 99% of his theories, but he was wrong on the Eisenberg Podolsky, or what was it again? No, Rosenberg or something paradox. And that's where Niels Bohr proved him wrong. So he's definitely one of the greatest scientists of all time. Wait a minute. Okay. But I digress. Where did I leave off on this? The sclerotic and cornea form the tunic of the eyeball. Did I read that yet? Whatever. I'll just start with the structure. The sclerotic is found of white fibrous tissue intermixed with the fine elastic fibers and of flattened connective tissue corpuscles, some of which are pigmented, contained in cell spaces between the fibers. These fibers are aggregated in the bundles, which are arranged chiefly into a longitudinal direction. It yields gelatin on boiling. Its vessels are not numerous, the capillaries being of small size, uniting at long and wide intervals. Its nerves are derived from the ciliary nerves, but their exact mode of ending is not known. Okay. The cornea is the projecting transparent part of the external tunic of the eyeball and forms the anterior sixth of the globe. It is almost circular in shape, occasionally a little broader in the transverse than the vertical direction. It is convex anteriorly and projects forward the sclerotic in the same manner that a watch glass does from its case. Its degree of its curvature varies in different individuals, and in the same individual or different part of the life is being more prominent in youth than in advanced life when it becomes flattened. The cornea is dense and is of uniform thickness throughout. Its posterior surface is perfectly circular in outline and exceeds the anterior surface slightly in extent from the latter being overlapped with the sclerotic. The spaces are stellate in shape and have numerous offsets, but they communicate with each other. All right, whatever. Okay, so that was a little bit of the that was fun with Grey's Anatomy. I hope you'll join me soon for my upcoming live YouTube sessions. Let's see. So it kind of makes you think. I mean, like learning about Grey's Anatomy, it's like, how do you, you know, the goal in life is longevity. You want to live the longest possible life, but you want to get to the point where you're actually just like on your deathbed and you're just like riddled with illness. So up to a point. So you want to live like, you want to like healthy in body, mind, spirit, and soul. That should be the goal. You got to maintain your bodily health, and maintaining your bodily health is going to actually influence your mental health too. and vice versa. I mean, if you have a good positive mental attitude, you're gonna like want to take better care of your body too. And then you start to think like, why would you want to live to 100 in a world that where life is like so could be so such a struggle and so dangerous and so unpredictable? Because all these things being considered, it's all you've got. If you got this one life and you got to live the best possible life you can. And I don't think you have to like be in perfect shape to live the most. You don't have, I mean, I'm probably about 40 pounds overweight. And I don't think, I don't think it's essential to having great health that you have to be like in perfect shape. I mean, I still eat a lot of bad food, but I eat a lot of good food. Um, I believe in balance. I believe in, I mean, you are going to die. That's a fact. I mean, just the fact that you're made out of flesh and blood, and you're not made of anything like, just means that it's a temporal, fleeting life, and got to live the best possible life you can. And I do believe that a positive mental attitude and a life affirming, sending out good vibes into the atmosphere on a collective level is better for the collective mental health of a community, of a society, of the world at large. So it all starts with one person. Okay, so I'll see you soon.